Hello and welcome to a Math Moment with Mr. Metelsky. Today we're going to be looking at stem and leaf plots, and we're going to do two examples together. And a stem and leaf plot is basically a way to organize data, like we have in problem number 1, in a way that gives us an idea of how far apart the data is, to see if there's any centers or sort of concentrations within the data. So in problem 1, it says the data for the production of number of components at an industry for 3 weeks are given below. Make a stem and leaf plot. I have a couple hints over here to the right. The first hint is identify the minimum and maximum values. So the minimum is the smallest. Well, let's take a look here and see. We've got 13. That seems to be the one, so I'm going to put a circle around that. And the maximum, here's 56. I don't think there's anything else bigger than that, so we're going to put a circle around that. So that means that our data in our stem and leaf plot has to range from 13 to 56. Well, the word leaf always refers to the ones position. And the stem always refers to everything else. Now, since we're dealing with numbers that are all below 100, that means that we're only dealing with ones and tens digits. So the smallest 10 we have is actually the tens, and then it goes 20s, 30s, 40s, 50s, and it ends at 56. So in the stem column, I'm going to put 1, 2, 3, 4, and 5. And that will then cover all of the stems because we go from 13 to 56. Now at this point we have to be a little careful, and what we want to do now is list all of the data points, but only write the leaves down in the leaf column. So 13 is our minimum, and I'm going to cross that out and I'm going to write a 3. So 1, 3, that would be 13. Now if I keep looking at my data set above here, I notice that I also have an 18 and I have a 15. So 15 smaller, so I'm going to put that next. And then I have 18, so I'm going to cross that out and put that next. So even though it reads 358, these numbers are really 13, 15, and 18. And then I'm going to move to my 20s bracket. I have 22, 24, 26, 26. So 22, 24, 26, and 26. And I'm going to cross all those out as well. And notice how I have them all matched up so that everything's evenly spaced. We want to be very careful with our organization here. Okay, the 3s. We've got a 39, a 34, a 38. So 34, 38, and 39. Now we take a look at the 40s, which we've got 45, 45. Well, that's it. There's two 45, so we're going to list 5, and then 5. And then last but not least, we've got our 56, our 51, and our 55. So it'd be 51, 55, 56. Now we have our nice organized stem and leaf plot, and the last thing that we need to do is to make sure that we write a key or a legend so that we know that the 5-5 really represents the number 55. Okay? So again, just to reiterate, we identified the minimum and maximum. Then what we did was in each stem, we evenly spaced and we wrote from smallest to largest, and we wrote our key. Now, I always like to go back later and count just to make sure that we have the same amount of data points in the original and in our stem and leaf plot. So let's go ahead and count. We've got 1, there's 15 different data elements up here, and we've got 15 data elements down there. So that means we've constructed a successful stem and leaf plot. Now let's try one more example together. It says the data for air traffic in 10 days at a busy airport is recorded as follows. Make a stem and leaf plot for the given data. This time you can notice that we've got 3-digit numbers. So let's identify again the minimum and the maximum. Let's see, we've got 287, here's 285, 281. This looks like this is the minimum, 281. And then the maximum we've got, well, 309. We've got some 306s, but they're not as big, so 309. So that means we've got to go from 281 to 309. Now, like I said before, the leaves are only the last digit, so the last digit 1 and the last digit 9 here. But the stems now are 2 digits. The smallest stem we have is 28, the biggest stem 30. So what we would do is list them out, 28, 29, and 30. And now we just list each number in order, evenly spaced, starting with 281. So 281. Now, are there any other 280s? There's a 285, a 288, and a 287. So 285, 288, 287. So I would assume the 5 goes first. Then we've got the 87. And then the 88. Notice how I'm trying to evenly space these apart from one another. Now we go to the 290s. We've got 294, 295, 293. So we have 293, 294, 295. And then in the 300s, we've got the 306, 306, and 309. So 6, 6, 9. And we want to make sure that we write a key. So in our case, if we would see something like 29/5, that really represents 295. All right, I hope we learned something about stem and leaf plots. Key is to keep organized, and you'll do fine. This has been another Math Moment with Mr. Metowski.